storage since 2008 or 9, right around that time period. Actually, right around the time when I founded SepiSolar, right around the same time also founded a company which ended up becoming NG Storage in 2015 or 16 when the acquisition took place. So I'm really excited to take everything that I've learned and figured out over the many years here at SepiSolar and through our experience with our partners like Green Charge and others to help everybody sell storage. John, you want to introduce yourself?
Sure. Thanks, Josh. My name is John Henley. I've been in solar since 2010, working alongside Josh for all of those 8 years. And for me personally, storage is extremely exciting because solar needs help from storage. The two partner so well together. Storage is complex and dynamic and challenging for us engineers, and so we love the opportunity to communicate how it works and how it can save customers money and how you can sell it informatively.
Awesome. Yeah, so John has been a wizard at figuring out how to make money with storage and all the modeling and policy compliance, code compliance, and just implementation, execution of the project. So from a holistic perspective, I feel like we've got some awesome experience to share with you, both on the sales side as well as execution development. We'll focus mainly on the sales side, but of course, so many things inform how you sell and develop storage projects. So wanted to make sure that we bring all that experience to the table and share it with all of you. So I mean, just to kick it off, I mean, one thing I did want to share with all of you was how I came to sell my first storage project. So in 2008, co-founding Green Charge Networks. To make a long story short, did a lot of great work in New York City, but it was all government funded. It was all DOE funded, so it wasn't going up to private industry and figuring out how to solve everybody's individual problems. It was more, proving to the government that C&I storage on the customer side of the meter can be done, and we demonstrated that with lithium batteries in those days. In about 2011, 2012, moved the company to California, or away from New York, and started focusing on the California market. And I learned a lot really quickly. I mean, aside from stop talking about technology and batteries, you talk about money and cash and how money ends up going away from the utility company and into the ratepayer, the consumer's pockets. I mean, that's what's important. To also, I mean, just solving a lot of problems, and that's why I think an energy storage system is it's a dream project or a dream product for engineers, because it's a financial problem, it's a technical problem, and it's also a sales problem. How to articulate these systems in the private sector can be extremely complex and difficult. And just exactly as John mentioned, I mean, one of the accelerators for that has been not talking about storage, but talking about solar, or even solar plus storage. So, I mean, actually, it was a dark night in the middle of 2010 or 2011. I discovered that in those days, SCHIP has been around for a long time in California, but what I had just learned was that in about 2011, 2012 timeframe, the Self-Generation Incentive Program, which is the incentive program in California, lifted the requirement that storage had to be connected to a renewable source. In other words, SCHIP for the first time could apply to standalone storage, and that just came through. And I think it was the 2011-2012 timeframe, and that caught my attention first. At the time through SepiSolar, we had been doing a lot of preliminary layouts and plan sets for commercial projects that were pre-sale. And I noticed that they were just falling through. We did preliminary designs, but never developed the full permit package. And curious as to why that was. After speaking with our clients, found out, the answer was always hard to get to. How come this solar project didn't go through? Well, it wasn't making enough money. Well, why wasn't it making enough money? Well, it wasn't offsetting a big enough chunk of their bill to matter. Well, why wasn't it offsetting more of their bill? Well, there were these, the accountant or the CFO didn't think it really penciled. Why didn't it pencil? Well, there's this other component called demand charges that, the solar doesn't, touch or impact. And, so all the solar in the world was only making a, 20 or 30%, 40% dent in their bill. And that wasn't enough to get interested. Well, what are these demand charges and how are they structured? And just blanks, in the 2011, 2012, nobody was talking about demand reduction. It was, at least not in a context of solar. It was this barrier, this obstacle salespeople had to work around, and finance people had to work around. So what that made me realize was that solar wasn't solving the whole problem, and that there was this component called demand charges. We did in those days, it was 2012 that we developed our very first financial model for storage with demand reduction. And turns out, when you factored in ITC and S-chip and solar projects and all the rest, and either standalone storage or with solar, you could find all these, you could find incentives and new revenues and different cost structures, depending on whether you do DC and AC coupling, which we'll talk about in a minute. And now I think everybody understands demand reduction. Happy to go into it here if the question comes up, but essentially, for me anyway, selling storage was about solving a problem. In that particular case, it was about saving solar. Solar salespeople were losing deals for no other reason than solar just doesn't do a good job addressing demand reduction. And that was a solvable problem with a battery. So how to model that, how to calculate it, how to convince others that the rate structures support that and that the utilities will also allow interconnection. Figuring all that out was the subsequent development work to solve what that core problem was. So in my mind, selling C&I storage really is about solving problems, and in our case, in the storage case, we're pioneers right now. I mean, it's a very early industry. People make a lot of analogies to solar back in 2003 and 2004. So that's kind of where we're at, I feel like, with storage today.
All right. I think right now we are going to open the lines for your questions. Once again, to remind people on the phone, you'll get prompted in a second. So to ask your question, press *6. And if you're listening to this and watching this online, make sure that your audio is connected and that you're off mute. Well, actually, you're going to be on mute automatically, but you'll see a prompt appear on your screen, and then just click on that to ask your question, and you'll be put onto the queue, and we'll answer them one by one down the line. So here we go.
Hello, you're on the air.
Yep. Waiting for first question. Who's going to be number one? Oh, you guys are all shy. All right, we have one question. Here we go. Hi, you're live.
What's the size minimum to go to a battery backup for your demand reduction? Is it like 250 kW or half a megawatt? This is John Turner out in Fresno.
Oh, okay, yeah, thanks, John. So the question is, what's the minimum size storage required to offset demands, like to perform demand reduction?
Yeah.
John, you want to take that one?
Okay, hey John Turner, thanks for calling in. You can do a lot more with less than 250 kilowatts. Demand reduction, you're talking about, spikes in someone's load that can last from 10 minutes to a couple of hours. 250 kilowatts, maybe for a commercial facility that's consuming several megawatts. But what I would say is, if you've got a customer with a base load of, I'm just going to pick a number, 500 kilowatts, you can do an awful lot of demand charge reduction with just 50 to 80 kilowatt system on a facility like that. You don't need, I would say, 10 to 20% of what their demand charges are. If it's 500 kilowatts, pick something 10 to 25% of that, and you can do an incredible amount of demand reduction with a battery that size.
Yeah. Yeah.
Okay. Nice.
Yeah. What's interesting, just to echo what John is saying too, what's interesting about storage that I think is also fundamentally different than solar, in solar, it is kind of a go big or go home strategy. The bigger the better. With storage, it's more of an optimization problem. So you're surgically sizing just the right Goldilocks size that's not too big where the battery gets expensive, but not too small where you're leaving money on the table to exactly solve a problem. And so because of that optimization, I mean, I get surprised on a regular basis. I don't know if you do anymore, but I've found, you know, really huge sites that I would have expected a ginormous storage system, maybe a small one takes care of it, and vice versa. Small systems, I wouldn't have expected needed such a big storage system. So it kind of goes both ways, and it depends, too, on what problem you're solving. There's demand reduction, that's one, but there's also rate shifting, for example, like just as an example, in California, there's GS2 and GS1 in SCE territory. One of those rates doesn't have demand charges and the other does. And so even though those are smaller commercial tariff rates, and you see a lot of small retail or small commercial offices on those rates, you might need either a very small or a very large battery to shift them away from GS2 onto GS1. And now we're not reducing demand, we're eliminating it by putting them on a rate that has zero demand associated with it. And it really goes both ways, and it depends on what problem you're solving.
All right. Does that answer your question, John?
Yep.
All right. We're going to move on to the next question. Thanks so much. Hi, you're on with Ask SepiSolar Anything.
Hi, good morning, guys. Ron Doris here.
Hey, good morning, Ron.
How are you?
Good, good.
Good. Thanks for asking.
Yeah. Bunnies. We are, incredibly small, predominantly residential solar, and I'm not that familiar with demand charges. We don't seem to get exposed to that very often, if at all, and so. But I'm keenly interested in storage and what it can do for residential customers as well. And so I don't even really know what questions to ask. I'm just grateful you guys are throwing this out here where I can just sit back and listen. But you got any beginner's advice on this?
Well, what tips would you ask? I mean, just to interpret you, Ron, what would you ask a customer to qualify them for solar? I mean, for storage. I think that's what. Am I answering? Rephrasing your question right? I mean, if you're
here's what we are experiencing now. Almost any time we start talking solar with somebody, storage comes up, and it's brought up typically by them. So there's been a lot of exposure of batteries and storage out there, and so we're just starting to get ourselves familiarized with this. And I get the piece where as the sun goes down, you're using your batteries, and with your residential rate, you're not in the duck curve. I don't know. You're keeping your bill low and everything, but there just seems to be so much more beyond that. More sophisticated levels of what batteries do and how to design, and even at a residential level. I cannot tell you how many people that we've talked to that they have a deposit on a Tesla battery and have no idea what they're getting or when they're going to get it. And then you hear other things about life cycles and blah, blah, blah. So there's just a lot of information out there, and I'm trying to sort out what is useful and accurate for my customers and get rid of the fluff. And so I'm completely novice at this. So I don't know, other than people want to reduce their energy bills. People up here where we are would love to be completely disassociated with the utility.
Get
a lot of that. So pretty broad. Sorry.
No, it's great. It's great. I hear where you're coming from. If you haven't had a lot of extensive experience in storage, it can be very daunting. It's solar is kind of solar comes much more naturally, I think. You can always. I mean, this is going way back in 2004. I mean, you could sell solar by saying, you know, sunlight comes in and money comes out, and you can explain all the details in between, but you can visualize that. Yeah, there's this resource in the world, it's sunlight, and it converts into money in your pocket at the end of the day. Storage is a magic box that sits next to your meter and might somehow save you money, but the nuances of that are so much more complicated. And this is probably a great Ask Me Anything show for another time to talk about how to sell residential storage. So Tor, we should definitely
on the list.
Let's add that to the list. What I will say though is, and I completely identify, I don't think there's a single person in the world who's ever had a conversation with a customer about solar that hasn't heard, well, does it work when the grid goes down? Or does it work, you know, what do I do? What do you mean it turns off when there's an outage or the grid goes out of spec? Or what about batteries? It naturally comes up. And actually, ironically, we all have a lot of experience with batteries already. We just don't realize it or appreciate it. It's called net energy metering. NEM is the process of turning the grid into a giant battery for every single solar customer. So we're already familiar with the concept. You send energy into the grid. When you overgenerate, you pull it when you need it, and you just treat the grid like a ginormous battery. And that is becoming expensive. The solar industry has not had to pay for that for a very long time, and it's starting to come up now with non-bypassable charges and NEM 2.0 and 3.0, which are currently in the works. So anyway, it will become a reality, like things, maybe, hopefully not, but maybe things like demand charges or other things. Customers will start having to worry about this. For now, what I would say on the residential side is storage, because the prices are coming down, battery backup used to be very expensive and very complex, and there were very few service providers that could understand it and put it together for you. It was very complicated. You had to buy charge controllers from one person, a transfer switch from another, inverter chargers from someone else, and you had to integrate this all together out in the field. Nowadays, they're getting much more productized, and what you get for that is backup. That's kind of obvious. When the grid goes down, you can keep the solar running with a storage system that essentially simulates a grid and keeps the solar thinking it's on and continues to produce power and balances load with supply accordingly. That's tried and true. That's nothing new. It's been around a long time. There are also areas of the planet where there is no net energy metering, or net energy metering might not compensate solar owners fairly, like maybe, you know, when as long as you use your own solar, you offset your load 1-to-1 with the utility. But if you export power past the meter, if you run the meter backwards, some people, some areas of the country are not getting reimbursed for that, or not getting as reimbursed for that. And that may become a reality for California in the not too distant future. It depends on how well CalSun, all of us work together. But essentially, you can use storage for what's called self-consumption, which is a common phrase thrown around, which basically means you keep the solar energy for yourself. You don't export it out into the grid. So right now when you install a solar system, some of the energy goes into your loads, into your home, some of it goes out into the grid. A storage system could prevent the solar going out into the grid. You could store it in your battery, use it for later. That's very common in Hawaii right now, which doesn't have, which has these kinds of funky NEM rules. For the moment, one more application that I've seen in Resi, and again, we'll have to go into more detail in another talk, but you can use storage to actually prolong the solar. When you go over into the next tier, basically, because in residential in California you have tiered systems, so once you get past a threshold, the utility pushes you into a more expensive tier. You can use the storage to basically help push off getting onto those tiers a little longer. So, and that requires some charging from the grid and not being able to discharge into the grid. So there are some complexities there that I can't go into. But so to sum it up, keep you off expensive tiers, self-consume your solar, or backup. Those are sort of the three revenue streams or value adds we see for residential storage today. Sorry, that was a quick answer.
Wow, thank you. That helps.
Okay, we're going to go on to the next question. 1 second. Here we go. Hey, you're on with Ask SepiSolar Anything.
Hey guys, how you doing? Mark Chapman here.
Hey, Mark. Glad to have you.
Hey, thanks. So yeah, just wanted to ask a quick question as it pertains to system sizing for both C&I solar and solar plus storage, and if it makes any difference based on the solar system size to bring up any opportunities for either AC or DC coupled storage, and what you guys are seeing in that respect.
Okay, excellent. This reminds me of a project we did very recently, actually. When you mentioned DC coupling, one of the advantages we've seen from that is very, very high DC to AC ratios. So the particular project in mind that we did just recently was an agricultural project. The nearby PG&E transformer was only 750 kilowatts. So putting in a solar any larger than that would require a transformer upgrade, completely kills the financials of the project. So with DC coupling, we keep our AC power at just 750 kilowatts, so there's no infrastructure upgrades needed. But on the solar and storage side with DC coupling, we had, I want to say, 2 or 2.2 megawatts of solar with adequate battery sizing so that we wouldn't experience significant clipping of the PV energy. So that's one of our favorite ways to use DC coupling, is to keep the AC system small enough that we don't have to pay for these infrastructure upgrades, but you get the largest array possible. I hope that helps answer your question.
Yeah, it does. Thanks. I was also just kind of curious, if you are limited on the size of the solar system at the site, if that changes the sizing of the storage system, optimization.
Yeah. What I've noticed is it's not so much there's a limitation on the solar system size, but rather there's a limitation on how much power the utility can take at that exact location on the grid. And that is a discovery process, unfortunately, because different parts of the grid are more saturated than others with stuff going on, either a lot of load or a renewable source. So what you end up finding often after the sale closes or in the utility interconnection process is, oh, sorry, this part of the grid, yeah, we can only take 500 kilowatts right here, or 1 megawatt, or 1.2, and that's it. And so the challenge then becomes, how do you get all the energy the customer needs without all the power impact that the utility can't take, or that they can take if they get to charge you an arm and a leg and your firstborn for it. So with the model that John was talking about, allows the customer to keep all the energy they want. It gives the utility less power which is what they want, and you, the developer integrator, get to sell more stuff and provide a more holistic service. So it's win-win-win across the board.
Got it. Thanks.
All right, we got another question. Moving on.
Good. Thanks, Joel.
Mark?
Oh, yeah, we're talking about
1 second.
Yeah.
Here we go. Tim, you're on.
Yeah, hi. This is Tim from Winona, Minnesota. How are you doing?
Hey, Tim. Good.
My question is, you said something earlier about that you need to optimize the system, and also I've been trying to find information to do a return on investments, doing peak shaving. For one of my clients, they could take probably around, they do about 2 megawatt hours per year. Their demand is about 360 kilowatt on average. So I'm just kind of curious, what's out there? Do you guys offer anything like that for like return on investment calculators, or how to optimize the system? I'm fairly new to all this, and that's what I'm looking for right now.
You have come to the right place. Yes, we do quite a lot of financial modeling, ROI, IRR, net present value, revenue modeling, and also factoring in the cost structures of different storage technologies and their warranties to make sure all the money going into a project and all the money coming out of a project all get factored and calculated. And so absolutely, it is, unfortunately, in storage, it is not as plug and play, if you will, or off the shelf. I mean, there are some tools out there that solve part of that problem, but at SepiSolar, we really want to provide a customized, tailored service to do exactly that for any project. And so if you get in touch with us through SepiSolar.com, we'll absolutely reach out to you and start to figure out more project details and get you what you need. Financial performance is exactly what we do.
Okay, I was also curious, do you use the algorithms from the different company storage technologies in your calculations?
Great question. Yeah, every EMS, energy management system, is a little different. Every battery system and underlying battery technology is a little different. Actually, even the exact same technology can be different from company to company depending on how they structure their warranties. So yes, we do take those into account, we do take those into account. It depends on the challenge with those is how much detail we want to go into, because at some point it may make sense, it's the old-fashioned 80-20 rule. We can get a 90 or 95% accurate IRR and all those revenue calculations. And then with twice as much work or 3 times as much work, we can get that last 5%. And we'll work with you, figure out where's the good boundary to draw, where we're comfortable and confident with the results that we can stop there and get you what you need.
Okay, so you have, say, calculated out some of these and then compared them to the actual results later just to see if your financial model, how accurate it was?
That's yes. I'm so glad you asked, because I've noticed a lot of deficiencies in the market as a whole, and that's one of them. You have a lot of, really anybody with an Excel spreadsheet, can generate models and tools to look at this stuff, but making sure that what you simulate or model actually translates into the real world in an active, real-time command and control operation on a storage system is critical. And that's we're right in the thick of it. Like we're proposing and analyzing these systems as a service, and then we're going back and making sure that whatever was simulated actually performed. And the discrepancies that we have found in those, sometimes they're related to swaps or changes being made out into the field. Sometimes the EMS provider changes and updates their algorithms downstream from us, and so there's a feedback loop there that's really critical to support and maintain. And so any partners, and we can even make recommendations for good hardware and software partners to work with to make sure that that feedback loop and that everything you're being provided is actually representative of what's actually going to perform out in the real world. Yeah, that is a challenge. That's an ongoing challenge to keep those things reconciled and up to date.
Okay, thank you very much.
Sure. Thanks, Tim.
All right. We have one question, 1 second. Kyle, he asks, let me just to repeat the question here. I'm going to read it for you, Kyle. Morning, everyone. The question I have is, have you seen the storage marketplace developers deploying storage asset on projects that were previously only generation assets? For example, only generation made sense 5 years ago for the customer, but now storage does, and so the developer is returning to the customer to add storage to the generation assets.
Yeah. Do you want
for this particular job? Only this particular job.
Thanks, Kyle.
We have no other current limiting devices in between the disconnect and the array.
Yep.
So those 20 amp fuses are the limiters for the rest of the solar.
I don't know what he's talking about. Hey, Tim, I think you're still on. I'm going to cut you off.
Yeah, I wasn't sure if that was Tim's question or Kyle's question.
That was Kyle's question. I'm going to cut you off now, Tim.
Go ahead.
Okay.
With Kyle's. Okay, so sorry, to respond to Kyle's question about generation assets, I'm not sure what, we see a lot of that. We see a lot of traditional run-of-the-mill generators, solar mostly, but a little bit of wind in there and some others, where we're looking at storage to basically retrofit to the system to solve a problem, either to add value sometimes, just increase revenue because it's possible, or two, to recover otherwise lost revenue, like curtailment, which is starting to happen at the utility scale on a much more frequent basis, or recover clipping. You know, some systems have been installed with very large DC to AC ratios, and with some analysis you can find there's a lot of money to be salvaged just in recovering clipping. So, I mean, clipping, curtailment, and then just enhancement of a renewable generator are ways I've seen storage come into the equation and add more money to the project. I don't know if did that address did that address the question?
Yeah, I believe it did. Tim can't hear anything right now. Hold on a second. Yes, Kyle says he did.
Okay.
Tim,
should we go to the next question?
Hey, Tim, you're on again. Are you there? Tim?
Glitch.
Yeah, you might be on mute. Yeah, we're going to have to go on to the next question, Tim. Try signing on again if you can hear us. Let me just signing on again. Okay. All right. So if you're on the phone, dial *6 to ask a question. If you're on the web, you should see a prompt right now. Anybody have any questions? If not, what would
okay.
We got one. Okay. Hi, you're on with Ask SepiSolar Anything.
Waveguide, Wave Energy Renewable, doing some work for irrigation district, and they want to kind of store when they pump a bunch of water, they have a way to reclaim some of that energy. They got 400 horsepower wells in the valley here. Yeah. Is there a way we can store some of that reclaimed energy so they can use it when they're in their big pumping times? It's low head, but they have a device that seems to work pretty good. A guy invented it, and it's over there in the west side area.
So, I mean, I know Imperial Valley Irrigation District has a ton of renewable out there too. Generation is quite easy to come by. So, I mean, you could store that and use it later to run the pumps. I mean, that's an idea.
Yeah, they get killed on demand charges when they fire up the 400 horse, no matter what they do on the starters and such like that. They're also going into solar and other stuff like that, and you know, they're the big boys. They have big power demands, but I was just curious.
Yeah. Yeah, that's
okay.
exactly.
I'll keep the post.
Yeah, that actually that's kind of the mainstream application for storage right now. It's to offset these big spiky, peaky pumps or compressors or motors that surge and spike. That's a very common application. Electric vehicle chargers are also somewhat analogous. I mean, some of those level 3, you know, like 60 kilowatt, 480 volt puppies are just pulling, you know, 1 minute they're at 0, another minute they're at 60 kilowatts for 30 minutes, and then they're off again and on again. And
they're that big now, huh? Okay, because we're doing a service center for one of the utility companies here, and they want to go net zero. So I thought, well, I'll call you guys and get involved and see what else we can do. But the big thing is storage, and luckily we have a lot of sun here in the valley. But also it's, you know, you're kind of working directly with the utility company, which is an advantage in some ways.
Right.
Okay. All right. I was just curious on that waveguide stuff. I'm more curious than how feasible it might be, but I think the battery storage on those solar PV is the best way to go on it.
Yeah. Yeah, there's definitely
thanks, guys.
There. You got it. Thanks so much for calling.
Okay. We've got another question. Coming back from Kyle. The question is, does SEPI handle off-grid projects, example microgrid with solar plus storage plus a generator, as well as only grid-tied? Thanks. Absolutely.
Yep. You want to? Yeah,
go ahead.
Absolutely. Yeah. So I mean, we've looked at systems, so solar with and without storage, with and without a generator and a grid connection, and the running definition I think that most people are currently agreeing with, although it does change a little bit, of microgrid is to have some kind of fuel-based generator and solar working together with a battery in between, with a battery managing all that energy generation and usage. Whether or not you have a grid connection or not, I've noticed some microgrids do have a grid connection, some microgrids don't, and some do that are sometimes on and off. So I'll leave that alone for a moment. But yeah, so we've looked at all flavors and combinations of those types of microgrids, and definitely the challenge, sizing storage for supply and demand, basically. I mean, it's all the things you worry about at the macro grid scale, but you're doing it on a tiny microgrid. So it's sizing all those components together to work cohesively is, of course, critical and important, but that's not even the hard part. The hard part is the integration of all those, getting all the parts and pieces to talk to each other, making sure the loads will continue to operate with the various sources of supply. So yeah, that is something we've looked at. There are a lot of nuances. A lot of experience has gone into the microgrid side.
Who's on from 559 number? Is somebody? I think we've got. Is somebody on starting with a 559 number with 437? Hello? I don't want to cut off anybody. Okay. One question I have about microgrids for you, Josh, is like, when does a commercial customer need a microgrid as opposed to just solar plus storage? Is there some way to define that for people?
Yeah, I would say. So there's so many ways microgrids come into play. One is if you have a bad grid connection. So we've worked with customers who are on the end of a distribution line, say a 12 kV line out in the middle of Arizona or any state, I mean, middle of nowhere, and it will be prohibitively expensive to build up the entire infrastructure of the grid to that location. So they end up with a crappy connection. And you can supplement that crappy connection with a beefier, sturdier, end-of-the-line solar plus storage system. It isn't as simple as it sounds. I mean, you need something that can handle sometimes a wider frequency or wider voltage range, and you need storage to support that often. So yeah, so that's one case where you might see a microgrid where it's solar plus storage and just with a crappy grid connection. As the grid connection gets worse, you will definitely want solar storage and a generator, a fuel-based generator. And then the goal of the solar and the storage in that case is to minimize the use of the generator as much as possible. And you can size those things up, as you please, the solar and the storage to try to take care of as much of the supply you need as possible, 24/7. And then you see microgrids. I mean, literally, we modeled a project in Myanmar, right? Just very recently, where you've got a community of a village basically, and the local generator company is reaching the end of their lease or whatever, or they want to expand the village and they don't want to be a victim to the big diesel conglomerates and all the gas companies that sometimes. I'll just leave it at that. So, to make people a little more independent from the market fluctuations and dynamics that come into buying gas and diesel. So, solar storage and a fuel-based generator together, totally off-grid, no grid connection whatsoever, is also, we see that pretty commonly, but I would say in developing countries more so than not on those kinds of systems. it almost looks like people in those countries, it's sort of like phone lines, like we installed all these phone lines and then switched to wireless. Mm-hmm. It feels like they're skipping, they want to skip all the development we did for oil, gas, and coal and switch straight to renewables and basically microgrid configurations with renewables.
Cool. We don't have any questions right now. If you have a question and you're on the phone, dial *6. We got one in the chat session here. I think it's good. 1 second. Okay. Does SEPI provide any subscriber acquisition services for what would be a community solar project in certain regions? Maybe that's outside the range of you guys, which I understand. Yeah.
Yeah, like a subscribe. That almost sounds like an aggregator service where you could aggregate distributed resources to bid into various utility programs or set one up through a community choice aggregation sort of model. That's not something SepiSolar does, but we could absolutely refer you to people who do. There are a few of those, some of whom I think we like more than others. But yeah, there are aggregation services that can address that question that we could turn you on to. I would say reach out to us at SepiSolar.com or email Tor Valenza.
Valenza at SepiSolar.com, TOR.VALENZA at SepiSolar.
Yeah, or if you didn't get all that, just come to us through the website, to our contact us, and we'll get you routed to the right people.
Yeah. Next question. Let me. Any other questions? Okay, Josh, why don't you give another set of C&I selling tips to people?
Yeah, I mean, one thing we haven't, there's a lot of talk about demand reduction, but there are several things we haven't spoken about. Like, for example, time of use arbitrage. What is interesting to me, that this is more recent, like within the last 2 years, I've noticed a lot more opportunities for time of use arbitrage, meaning solar may generate in some off-peak periods and some part-peak periods and some on-peak periods. And naturally, you want as much of the solar to generate during on-peak as possible because that's where all the money is. There is a discussion to be had about demand reduction, and lots of battery technologies are good at solving that. But energy arbitrage is a little different. It requires that you interact with the solar system regularly, like every day. And one thing anybody who's worked with a lot of batteries knows, conventional batteries typically don't like to be cycled up and down full swings of depth of discharge every single day. So finding the right battery technology to work cohesively and seamlessly in a very tightly integrated fashion with a solar system where it modifies the shape of the solar generation profile to optimize revenue or maximize IRR is a challenge, and it's being met today. There are now battery technologies and systems that can cycle every single day, very deep, 100% depth of discharge cycles that pushes the energy from the solar around. I think of it as like a renewable optimizer, a renewable enhancer. You can't do it with just any technology because some battery technologies degrade rather quickly or rapidly, or they have high or low round-trip efficiencies. But there are some battery technologies that are tried and true, commercialized, they've been out a long time, that can cycle up and down every day with a solar system that enhances and optimizes that solar system for whatever tariff you're on. And that is where we're seeing a lot of revenue come up that people haven't really quite looked at very deeply, probably because there's a lot of inherent assumptions brought to us by lithium providers that we have to work around, and warranty compliances involved there. But I think as an industry, and that's very important. I mean, we needed lithium to get this energy storage industry kicked off, but I feel like we're now entering in a second stage where we have not newer technologies, but actually newer product configurations of older technologies that can sync better to solar systems than, say, what everybody thinks of as the lithium system, conventional lithium system today. And so we're trying to fit the right technology with the right application and optimize that for the customer.
Okay, we've got a question from Joel. The question is, we have a few customers that don't have historical usage data, and he's talking about marijuana grow facilities. Good for you, Joel. Rock on. Can they model their usage, or would you recommend that they wait until they've been up and running for at least a year?
Good question. I've definitely looked at grow facilities as well as blockchain. I don't know if anybody heard this, but actually just a few months ago, some blockchain companies were kicked out of Canada and are now trying to figure out how to start up microgrids because blockchain requires so much energy, as do grow farms, that the grid just can't handle it. And so that is a real problem. Big business, big corporation, or big facilities just are having trouble connecting the grid. So no, I don't think you have to wait for the system to get built, let a year go by, measure and monitor everything, and then do the solar and storage later. Absolutely not. I mean, that is one way to do it. That is a extremely conservative, slow and deliberate, logical way of doing it. Another way to do it, though, is, I mean, a lot of those loads that those facilities use and operate are very well understood. Like, for example, lighting. Not everybody. There's a lot of expertise around lighting, for example, and compressors and HVAC and humidifiers and things like that. So the more you know about the loads up front and how you expect them to be used, the more precise you can design a system around those loads. And I've done already some sizing analysis, actually some fairly deep analysis into those dynamics. And we may actually very soon have a project within a month or two that kicks off that does exactly that. So no, you don't need interval data up front. You just need a thorough understanding of the loads. It's a conversation we can have, or you can have with your customer. And it's not looking at spec sheets. It's really understanding the duty cycles, the ramp rates, surge, power quality, bars, all kinds of electrical engineering things that you would need to dive into, but it's a solvable problem.
Okay. Looking for some new questions. If you're on the phone, dial *6. If you're online, just look for the prompt and raise your hand.
We probably only have time for one more question, right?
Yeah, it is. It is towards the top of the hour, so this would be the last one. If not, we'd like to tell you a few more things.
I mean, I'll just say, demand reduction is great. I mentioned time of use arbitrage. I think we're going to start seeing a lot more infrastructure deferral. I mean, that's a huge breadwinner for storage. I just got one last week, a 2-megawatt system we designed in Lodi, California, just got kicked back by the utility because the grid can only take something like 500 or 600 kilowatts in that area. So, or you pay $1.5 million, $1.5 million to the utility to upgrade their infrastructure. So, I mean, that's not something you like to discover downstream from the sale, but it is good to know that as we go forward with these larger solar projects or more solar projects, that storage can come in and save the day. It's not, if you're encountering an issue with a utility company of any kind, whether it's power quality or capacity, whatever, I strongly encourage you to reach out to us, and we will look at it through the lens of storage for you to see if there's a solution there. I just see storage solving so many problems on the grid side right now because of the state of the grid today and how much solar is getting connected.
Josh, I'm gonna throw you an easy one. Where can people find more information and training about solar and storage these days?
Thank you, Tor. Yeah, we're also to help, talking about storage is one thing, and having, these Ask Me Anythings, I'm so excited to be doing and want to do more of them. But if you want to take another level up, basically, we're launching what we're calling SEPI Academy, which is a vocational or a hands-on training platform to bring actual real tools to you to use on a regular basis for exactly these types of projects and questions. So I would encourage you, anybody who's interested, please reach out to us at SepiSolar.com about SEPI Academy, and we'll plug you into our course syllabi that we have. And brochures and information that explain the value that you could get out of these trainings, because it's becoming more and more evident that there is so much organic, deep knowledge that is needed around these systems, and it's not something that can be easily done in a 45-minute or 50-minute web series. So I would encourage anybody who's interested to learn more and wants to get their hands dirty, maybe really dirty, to reach out to us about SEPI Academy. We'll get you some real tools and training on around these systems.
Our first two courses, which are going to give you NABCEP credits, CEUs, we are a registered provider of NABCEP CEUs, is going to be in October, mid-month. So check those out. We'll be offering advanced energy storage and system management, as well as advanced solar PV and system management. It'll be taught by Josh, and you can ask him anything at that course too. But right now, I think we are at the top of the hour. So unless there's any last-minute questions, I'm not seeing it. I think we're going to bring this to a close. But join us next month for another edition of Ask SepiSolar Anything. We haven't decided on the topic just yet, but it may be the residential version of this.
We've got one vote for residential. If anybody wants to hear about anything else, feel free to send us suggestions.
Yeah, and I also like to remind everybody that we are going to send a recording of this so you can listen to it again, share it with your friends. We had another second vote for residential. Excellent.
Awesome.
Yeah, we'll share this, and we'll let you know when the next one is. So thanks again for joining us. We love having these questions, and you can always email us at info@sepisolar.com to ask more questions, and we'll do that on a one-on-one basis. Thanks for showing up, and hope you go out and sell a lot of solar plus storage.
Thanks so much, everyone.